So,
Welcome to James Souls chemistry class. G-Block.
So, between people that have both done this and disagree, any disagreements on the front, 1 through 6. Problems you want me to do on the board from 1 through 6. You can you disagree on 6?
Could you do number 5?
Alright. Let's do a request for 5 and 6. I'll start with 5 because it comes first. So, I'm doing number 5 from the front. If you're just starting joining us with the homework, you should join us on
I
the
have a
front.
real quick question that applies to everything.
Yes.
When it's like silver or something in the middle, do you assume
Plus 2, if you don't otherwise. Alright, so number 5, sodium nitrate. So, sodium, Na. Okay, Sandra, what charge does sodium get based on its position on the periodic table?
Where is it?
On the far left. Number 11.
Plus 1.
Plus 1. Sodium is a plus 1. Key, based on memorizing the polyatomic ions, what is nitrate?
I need to NO3.
NO3, which gets what kind of charge?
-1.
-1. So, these two chemicals, when I put them together in well-dressed butts, what is that going to be? If I make these together, what's it going to be? What chemical is that going to make?
No, I do.
Just NaNO3. My point is that I don't need 2 of these or 3 of those. This thing, the charges are balanced, +1 and -1, so it just comes together 1 to 1. Yes, there may be a roll tide door flare in here somewhere. I don't know where it is. Jamie's got it. Jamie, help her out.
Throw it.
Okay, our other chemical is lead 2 oxide. Pb. The fact that they put a Roman numeral 2 on it refers to the charge on the metal. It is lead +2. Okay. I'll skip just as good. Hannah, oxygen, based on its position on the periodic table. What charge is oxygen likely to get? -2. So come back to justice when I have this is losing 2 electrons, this is gaining 2 electrons. How many of each do I need? What ratio am I going to combine these in? 1. This is 1 to 1. Okay? So this is just going to be PbO. These are my reactants. I've done this much work just to begin this problem. They combine. I'm going to slide them over here. Okay, and now do some of the new stuff. This, what I've been doing, is old stuff of putting ionic compounds together. Now I'm going to say combine to make. That was like the combine to make. Okay, lead 2 nitrate. So now it's Pb +2 NO3 -1. Okay, Elise, when I look at this, do I need more nitrates or more leads for this to be balanced? More nitrates. Because this is -1, that's +2. I need more nitrates. How many nitrates do I need, Elise? 2. So lead nitrate is going to be Pb parentheses NO3 2. Okay? Because I need 2 of these -1 charges to balance off that +2 charge to make my compound nice and balanced.
Don't you already have? Oh, we never.
Okay? And then I also have sodium oxide that I'm making. Sodium is +1, oxygen is -2. Cynthia, when you look at this, do I need more sodium or more oxygen for that charge to be balanced?
Sodium.
More sodium. How many sodiums am I going to need for this to be balanced? 2. I'm going to need 2 sodiums to get a +2 to balance off that -2. So plus Na2O. This is what we want for number 5. Okay, looking at what the charges are going to be to make the subscripts. The reactants are all 1 to 1, and the products they're 2 to 1. Okay. More questions on the front. Number 6.
Just generally.
What is your question generally?
When you say include states of matter,
Oh yeah. So for this one here, all of these I think we should assume is going to be aqueous. When you have a double replacement like this, it's all aqueous stuff.
so it matters on the type of reaction and not the elements included.
No, it's more, I didn't do a good job on this sheet of giving you the information you need. For some of them, where I say like calcium metal, like you know that metal is going to be solid. For other ones, I didn't give you good information. I happen to know that for a double replacement reaction, it's going to be aqueous.
So should we?
We will learn more that will tell us about states of matter as we go on. Hannah, question.
So should we write?
Aqueous, I'm telling it to you now, sure. That's good. That's a gift. Jamie, how?
explain, like, can you draw all the symbols for, like, decay, make, react, like, oh wait,
All of them are going to be an arrow going forward.
literally that's it.
That's it. We're saying before, after. Reactants, products. Doesn't matter what the words are. Yields, produces. Just arrow.
Does
Yep.
it have, can you switch it and then put the arrow in opposites?
You could. That looks a little weird. I would
Like
not,
if
I would
you-
give
if
you
you-
4 out of 5 for that answer.
You start off with the like what the production is,
Yes.
and then that's what I start to write down,
And
and
then
then
I tricked you, and yeah, you have to read it through first. It's not. It's going to take you less than 12 seconds to rewrite it, so it's.
Oh my god.
All right. So number 6, vanadium 5. The V in there is not giving you the symbol. That's giving you the charge. Vanadium is at a plus 5. And then problem number 6 in the front. Oxide. Okay. Sophia Webster, what charge does oxygen get based on its position on the periodic table? Negative what? Negative 2. So Declan, when I put these together, what is the formula of this compound going to be when I procedure X this thing?
Procedure. V2O5.
Correct. V2O5. Just drop those numbers down, and those become the other things. The charges become the other things number. All right. Now, the other chemical is calcium sulfide. Calcium. Jamie Harvey, looking at calcium, number 20, based on its position on the periodic table, what is its charge likely to be?
2.
Plus 2. Donnie, sulfur, number 9, what is that, 16? What charge is that going to be? Minus 2. So when I put this together, because of what's that going to make? Just CAS. Okay. React to form. Okay. Calcium oxide. Calcium plus 2. Oxygen minus 2. So that one really done is going to be CaO. Okay. And vanadium sulfide. Vanadium is once again plus 5. Sulfur is minus 2. When I put that together, Elias, what is this one's formula going to be?
V2S5.
V2S5.
Silver? It depends on what it says.
Okay. That is what this final answer should be, but I should put a little aqueous on all of those problems. Okay. Turn the piece of paper over. Wow, that was a really nice dog. Okay.
Thank you.
You made this?
Thank you.
So do I'm taking credit for that.
You're welcome.
Okay, so compare 7 through 13 real fast. Compare 7 through 13 really fast to the person next to you.
Oh yeah.
Have a good day.
Oh wait, hey, Justice.
Oh, you tried.
God, you were so
Alright. Alright, any good disagreements on 7 through 13? Going once.
Yes.
7 through 13, going twice. Elias.
8. Oh my god.
8. That is a double replacement reaction. Alright. I'm going to set this aside for right now because we do have some stuff that we need to learn to do today. So let's see if we have time to come back to more of it later. Go take out your notes books.
Yeah, I was